Hello, everyone. Thank you so much for being here today. Before I start, I want to apologize in advance because I have a little bit of a cough left over from being sick. And so at some point, I might have to cough to the mic, and you're all going to have to hear it. So sorry about that. But apart from that, today I'm here to just make you think of a world where you don't really have to use passwords anymore. And you might think that, for people in this industry like we are, or even people who are in the identity and access management industry, passwords are like, easier and everything is better and stuff. And the reality is that it's not. And I want to tell you about one of the many experiences I've had with passwords. So I want you to please raise your hand if you've ever been to a furniture shop and you're waiting to pay in this self-checkout cashier, and you're trying to pay with your credit card, but you don't remember your PIN, and so you try to recover your PIN, and then you need to remember your password to get into your bank's application, but then you don't remember your bank's application's password, and so you're just making people wait there for like 10 minutes. Awesome! I was not expecting to like that this happened to more people because it's very specific, but yes, this happened to me. I was in a very big furniture shop. You probably know it. I was trying to use my credit card. I couldn't recover my password at the time because of reasons. I couldn't use my face to log in with the app because, sometimes it's like, no, now we need your password. And you're like, what's my password? I don't know. And so that happened to me, and I was there for like 15 minutes struggling to pay. People were annoyed behind me. And that's really the thing about passwords. The thing about passwords is that they suck. They're the worst. I don't know if I can get anyone to agree with me on that one, or if you like passwords. Let's change that. Do you like passwords? You're taking no. I don't believe you. And one of the many problems with passwords is that they rely on your memory. And yes, I know for us in this industry, we probably use password managers, or we store passwords with like the Google password managers and all that kind of stuff, or use 1Password and stuff. But think about other people outside of the industry. Like I often think about my mom because I'm the password manager. I've had messages from my mom saying, what's my Gmail password? And I'm like, it's this one. And she's like, no, it says I changed it 3 months ago. And I'm like, well, you didn't update me, so how can I know? But yeah, the thing about passwords is that they're easy to forget, they rely on your memory, and they can be vulnerable for attackers, and they can be accessed by unauthorized people. That was my little rant about passwords, so let me introduce myself. My name is Carla. I'm a senior developer advocate at Auth0 by Okta. I've been working as a software engineer for about 10 years already. I make YouTube videos sometimes, although it's been quite a while. I probably should update that slide. And you can find me as Carla Stabile almost everywhere where it was available. But yeah, going back to, I had another disclaimer to make, is that there are some things that I might simplify in order to explain them in here. So very happy to talk about that later if you want. All right, so this is what we're gonna be covering today. We're gonna be talking about my dislike for passwords, which we already did. We're going to discuss some alternatives. We're going to talk briefly about WebAuthn, and then we're going to talk about passkeys. Before we begin, I would like to ask you if you know what passkeys are, so I can get like a sense of the room. Cool. Are you using passkeys? Awesome. That's great. I didn't see that many hands up, so hopefully at the end I change your mind. But yeah, going back to the password. So if we don't use passwords, what's the alternative? And the first thing that comes to mind is just passwordless. So we get rid of the password. And we have a few ways to implement passwordless. You've probably already used something like using a magic link. So you log into a service using your email, and then you get a link, and then you click on that link, and you are logged in. Or, for example, using a one-time password code sent to your SMS or something like that. Those are some forms of passwordless authentication. But like a formal, more fancy definition would be any form of authentication that doesn't require the user to use a password when they log in. And apart from those examples, I think we're going to be discussing a few other examples. There's also authenticator apps like Google Authenticator, for example. That could be an example. And I do personally think that passwordless is better than using a password. And I have a few reasons to believe that. The first one is that it improves the user experience. So as a user, you only need to remember, oh well, let's rephrase that. You need to remember less things, right? You need to either remember your email or your phone number, and then you can log in. You don't have to remember another password or like create a new one from your 10-year-old self password, that kind of stuff. It is more secure because the thing with passwords is that they can be vulnerable, as I said. We have this tendency to reuse passwords because we can only memorize a certain amount of passwords, and so we often reuse them or make little changes to them. And or we make little changes to them, and we also tend to share them with other people. And if I'm sure some of you have done it with some streaming services. I've done it, it's fine, but because of that, they're less secure than using passwords because you don't have anything to share in there. And finally, using passwordless reduces the cost of ownership. And I wrote in there both in time and emotionally. And let me explain why. So managing passwords is expensive. Not only you have to deal with storing passwords probably in your database, which I hope you do not do in plain text. You also have to ensure that you have password reset mechanisms, that your database is secure. But me personally, in the past, every time I've had to implement any like type of username and password authentication system, I always feel like, am I missing something? Like, is this enough? Like, there's always that like stress of, what am I missing, right? And that's what I mean with emotionally. And I think that if you felt this stress and you've dealt with the annoyances of passwords, like me, you were probably looking for a solution and you were wondering, okay, but how does passwordless even work? And to start talking about that, we first need to talk about authentication factors. And you probably already know them with some other names, but we have mainly 3 authenticator factors. We have knowledge, and that is proving your identity with something that you know, and that can be a password or the answer to a security question. You can also prove your identity with something that you have, and that is possession, so for example, with your device. And finally, we have proving your identity with with inherence, or something that you are, something that is inherent to you. And that, for example, can be any type of biometric, your fingerprint, your face, if you have use Face ID and stuff. And the thing with passwordless is we want to get rid of the knowledge factor, right? We don't want the user to use a password to use something that they know. So we're only remaining with the possession factor or the inherence factor. And the thing is that if we look at this diagram here that I made, there is a way for you to increment how sure you are the user is who they say they are, depending on how you mix authentication factors and authenticators. And I'll explain a bit in authenticators in just a minute. So if you look at this image, for example, if we go all the way to the, okay, we went to the right, I wanted to go to the left, but we're gonna go back. So if we look at this image on the right side, and that's when the right animation will come in, that's where we want to be, because that's when we have the highest assurance. That's when we're most sure that the user is who they say they are. Why? Because we will be using something called FIDO2 WebAuthn, which I will explain in a minute, and we can also use biometrics. The thing with FIDO2 and WebAuthn and why they're so secure is because they're based on public key cryptography, which is harder for attacker to guess, in your using your biometrics as well. Whilst if we go to the left side, we're talking about security questions and passwords, and that is something that people know. So it's very easier for an attacker to guess. Okay, so ideally, what we want to do in order to be completely sure that this user is who they say they are, is we want to increase the level of assurance. There are a few ways you can do that. I brought 3 here that we can discuss. The first one is using multi-factor authentication. The second one is using public key cryptography. And the last one is using authenticators that are phishing resistant. So let's talk about multi-factor authentication. If we go back to the image, we see that the authenticators on the left side, they're highly vulnerable, like I said, because they're based on an authenticator, which is your memory. Your brain is basically the authenticator, so they're easy to guess. They usually only support single-factor authentication, so they're not very secure. We want to keep increasing that. So if we move forward to the middle part, then we're talking about, okay, if we use SMS and voice and email and software one-time passwords, in this case, we want to use authenticators that ensure that you're using 2-factor authentication. That means that you are proving you are who you say you are with 2 different methods. And then finally, if we go to the last side, which is where we want to be, we need to use here authenticators that enforce multi-factor authentication. That is using 2 or more factors of authentication. And we also want to make sure that they have impersonation resistance, compromise resistance, and authentication intent. And those are very fancy words to a few things that I'm going to explain in just a minute. So basically, we want to be on the right side using authenticators that ensure MFA. That's the first step. Let's say we got that. So the second thing would be, okay, we need to use public key cryptography. Sorry. And you are probably very familiar with public key cryptography, but if you are not, you think, for example, when you use Git and you use your SSH keys, that's kind of like a form of using public key cryptography. And it basically consists on having a pair of keys. So you have a private key and a public key, and those keys complement each other. So the public key is obviously public for everyone. You can use it for anything. The private key is only available to you and should be kept completely private. So this is a little example here. Mati wants to send a message to Guri, and so he's encrypting the message using his public key, and then Guri is decrypting it using the private key. And then when he wants to reply back, he signs the message with the private key, and then Mati can verify it with the public key. That's what we mean, that they complement each other, because you need to use them both in order to get that message. So now we know that what the hell is public key cryptography, and that we ideally want to use an authenticator that enforces multi-factor authentication and public key cryptography. So what about phishing resistance? To guarantee phishing resistance, there must be proof of identity every step of the authentication process. And this is where WebAuthn comes into play. So WebAuthn is short for Web Authentication API, and is a browser API that allows servers to register and authenticate users using public key cryptography instead of a password. This is a W3C recommendation. It's available if you want to read it out. You can Google it. I forgot to put the QR code, but that's fine. And yeah, so using WebAuthn will actually ensure that you're using public key cryptography. That's great. But it would also ensure that you're using an authenticator that is like the ones we want to use. And I'm wondering if any one of you is familiar with any of these devices. Yes, I see a few hands. These are called security keys for those of you who, like me, a year ago had no idea of them. And you have like different models and brands. One of the most popular ones is this one, is the YubiKey by Yubico, but you also have like Google's Titan and whatnot. And these devices are called roaming authenticators. So they are devices that you can connect to your laptop, for example, and then the public key pair is always available there. Then we also can have platform authenticators, and that would be, for example, my Mac. If I wanted to use it to authenticate somewhere, this would be a platform authenticator, and that's because the authenticator is integrated into the device. And I want us to take a look now to how the WebAuthn architecture kind of looks like, and it's a little bit like this. So you have mainly three components, that is the authenticator, the client, and the relying party. The authenticator, as I think I've said that word like 20 times already. It could be one of those devices I showed in the picture. It could be your Mac. And as we said, it has to be an authenticator that enforces multi-factor authentication and uses public key cryptography. That is a requirement for this. And this device is actually the device in charge of creating public key pairs for you to authenticate later on. Then we have the client, which in WebAuthn is usually a web browser, but I think there are also some implementations on native platforms. And then we have the relying party, and that would be the server to which you're trying to authenticate to. So let's say, for example, you want to log into your Google account using WebAuthn. The relying party would be Google's server in this case. And then there's an extra step, let's call it like that, in this, and that is that there has to be some sort of user interaction. And this user interaction is called proving intent through deliberate action. And here we're kind of like guaranteeing that phishing resistance. So every time you want to create or you want to authenticate using WebAuthn, you need to confirm or attest that you actually want to do it. So in the case of using a YubiKey, every time you want to use it, you have to touch it. Or if you want to use, for example, your Mac's authenticator to log into somewhere, you have to put your fingerprint in your Touch ID, or put your face in your phone if you're using an iPhone, for example. So in WebAuthn, in each of these steps, there has to be some sort of verification so we can guarantee phishing resistance. Right. The communication between all these parts of the architecture happens like so. So the client communicates with the relying party using the WebAuthn API, because it's a JavaScript browser-based API, so they can talk like that. And the client and the authenticator communicate with each other through a protocol called the client-to-authenticator protocol. These are two standards, CTAP2 and WebAuthn, and they comprise what is known as FIDO2, the FIDO2 standards. And FIDO2 is a standard that was developed by the FIDO Alliance, and the FIDO Alliance is, it's an organization, and their mission is basically to reduce the reliance of users with passwords. So I share a goal with them. I don't know about you, so I want to keep implementing this stuff. If you want to learn more about this stuff, you can scan that QR code up there. Sorry. But right now, I'm just happy if you remember that there's something called FIDO2 and WebAuthn, and they take part in the architecture of WebAuthn, of course. All right, so I mentioned WebAuthn is an API, and it has a bunch of methods, but the two most important ones are the ones that allow you to create credentials, and that is you can use it, you can call it using navigator.credentials.create. And we have the get method, which is the one that you can use to authenticate yourself. So once you create a credential, you have to get it and verify that all the information there is true, and that would be how you authenticate it. And you use it with navigator.credentials.get. Normally at this point, I do a whole demo on how WebAuthn authentication look like, but there is another talk talking a little bit about passkeys in the front-end track, 3:45 tomorrow. And I think it makes more sense if you want to go take a look and see it there, and then here we can focus on like other stuff with passkeys. So if you want to go, feel free to go. I have nothing to do with it. I just think it's cool that there's two people talking about why we hate passwords, and yeah, feel free to go. All right. So we're increasing the level of assurance again. We have multi-factor authentication. We have public key cryptography. We're ensuring phishing resistance. And now we also talk about WebAuthn kind of in a little bit, but we want to comprise it all because I feel like we talked about it in like different phases, but we want to comprise it all in one thing, and that one thing is passkeys. And a passkey is nothing more than a unique cryptographic key pair that allows you to access online services without using passwords, and it's based on asymmetric public key cryptography. I like the name change because, you know, we were using random strings, which are words for passwords, and now we're using cryptographic key pairs for passkeys, so I think that was a good use of words in there. And I have a few like benefits or reasons to use passkeys, and one of them is that they are intuitive. Hopefully you can read that because I don't know if the contrast is good enough. They are intuitive. They create an experience that is familiar to end users because it feels like you're unlocking a secret, and I'll show you that in just a minute if my demo doesn't fail. They're secure. They're phishing-resistant. Why? Because they are using all of the other things we were talking just a minute ago. They use public key cryptography, the enforced multi-factor authentication. Then another reason is that they are non-reusable. There is no way you can use a passkey that was created for a website and use it in another website because they are bound to the domain they were created. And this is also another reason why they're phishing resistant. So usually if you have been a victim of a phishing attack, you get this email that looks so much like the real stuff, and then you hover on a link and you're like, that's not the right URL. So with passkeys, that can never happen because if the URL doesn't match, then you just cannot use it. And lastly, they're convenient. They allow you to access an application on multiple devices, and you can use biometrics or security keys and all of that. So technically speaking, and this is why I was talking about 502 and WebAuthn and all of that, like if you look for the formal definition of a passkey is a 502 discoverable credential. And it's a 502, so let's split that in 502 and discoverable credential, right? It's 502 because under the hood is using WebAuthn, and it's using the 502 standard, and it's comprising all that information that we just saw. And then the discoverable part, it's about, so when you use a passkey, the browser is able to detect which passkeys were created for that particular website. And that is what tells you how discoverable a passkey is. For example, if you were to use WebAuthn in a website and try to log in and you never get like the credentials suggested to you, that is not a discoverable credential. A passkey would be, because it would always be suggested to you by your browser. And we have two types of passkeys. We have sync passkeys, and those are the passkeys that you can sync to a cloud-based service, and they're available in multiple devices. For example, you can sync a passkey to your iCloud or to your Google account. And then we have device-bound passkeys, and those are passkeys that are stored in a single device only, and that's usually the device that they were created on. I want to point out that the difference, or like the main difference of the two passkeys, apart from being available on multiple devices and stuff, is of where does the private key lives. So if you remember, a passkey is a key pair and a public key cryptography pair. So we have a private key and a public key. In the sync passkey, you have to sync the private key to the cloud in order for it to be available on multiple devices. In the device-bound example, the private key never leaves your device. So if you're using, for example, a YubiKey, you know for a fact that your private key is in there and only in there. It's not synced to anywhere. So there's a lot of people thinking, then I want to have my private key always with me. I don't want to sync it anywhere. And when we get to the challenge part, I'll say why, and we'll understand why. All right, talked a lot about passkeys and stuff, but let's see them in action, because I think that's more interesting than hearing me talking. Hopefully, the demo works. So let me see if I can move this. Okay, it's running, so that's good at least. Okay, so sorry. So this is a small application that I wrote using Ruby on Rails because I like Rails. No other reasons. You can write it in whatever technology you want. And then what it does is it allows you to create a new passkey, read those passkeys, delete them. So it's like a passkeys manager app, I would say. So I'm going to go ahead and try to create one. I'm obviously using Auth0 because they pay my wage, and also because it's cool. So I'm going to try to create one new account. Let me think. Carla at DevBcn.com. Am I typing that right? Okay. So I'm going to click continue, and I'm being prompt or asked, so it's like, you're going to create a passkey. This is all the benefits you have. Are you sure you want to create this passkey? So I'm going to click on create a passkey. And then I'm presented with a few options. So the first thing is I can create a passkey in my iCloud keychain because I'm using a Mac. I can use a phone, a tablet, or a security key, or I can save it in my Chrome profile. For the sake of the demo, I'm going to create it on my phone, so at the same time I can show you how the multi-device experience feels like. So I'm going to go ahead and click on use phone, tablet, or security key. Where's my phone? Here. So let's see. I'm going to scan this QR code if it's readable. Can I read it from here? Yeah. Could also read it. Okay, so it's connecting to my device, and what my device is saying is you need to use Face ID to actually use that passkey. And this is that part of user interaction of like intent through deliberate action that we need to do. Like if I don't do anything for a while, this will time out and it will fail. So that's already stopping like any kind of automated attacks. So I'm gonna click continue, use my face, and now I should go back to my application. At this point, I'm already logged in, just asking me to authorize some stuff because I need to access my profile. And here I have my profile, and if I go to my passkeys, I can see that I have created a sync passkey with this information and that kind of stuff. I could also delete it, but I'm not going to do that right now because it will defeat the purpose of this demo. So that's how creating a passkey looks like. What happens when I later on want to use it? So I can click on the continue with a passkey. And remember a while ago when I was talking about discoverable credentials and how the browser can discover credentials? In this case, I'm using Chrome. And so Chrome is able to detect the passkeys created for this domain associated with me. So I have that one, which is not the one I want to use right now. So I'm going to click on use a different passkey, and I'm going to have it on another device. So once again, I'm going to scan this QR code, click on it. It's connecting to my device, and if you're a normal person, you shouldn't have like that many passkeys for one single website. I have a bunch because I've been testing this out. So I'm going to select the one I created, which was the Barcelona one. Click continue, use my face, and I should be authenticated now. This is a tricky part. Not a tricky part, but just an interesting part is that with the Auth0 implementation, Auth0 will always ask you if you want to create the passkey in the device you're using at the moment. So my passkey is created in my phone and is synced through my iCloud because I have an iPhone, but Auth0 wants to know if you want to create it in my Mac in this moment. I don't have my iCloud here, so that's why it's asking me. So I can just either create a new one or continue with the one that I already have. I'm going to continue with the one I already have, and if we go to my passkeys, then that's just one single passkeys there. All right. Let me see if I can bring my talk back. There we go. All right. Okay. So, I don't remember. Yeah, I had videos to support me in case I didn't have Wi-Fi. So I'm going to click next and next because I already showed you this. And I also want to keep it real because I come here and I tell you all the great things about passkeys and passwords suck, but we are still facing some challenges, so let's go through them. The first one is the operating system and browser support. So using a passkey depends a lot on the experience you get as a user. It depends a lot on the operating system you are and the browser that you're using. Because it's up to the browser and to the operating system to implement the specifications like WebAuthn and FIDO2 and all of that. And so you can have a fragmented experience. For example, I was using Chrome here, but if you use Safari, or even if you're on Linux, you might have a completely different experience. In fact, I don't think, for example, in Ubuntu, you don't get to use sync passkeys yet. And that's an example of how different the experience between browsers and operating systems can be. Don't ask me about Windows, because I don't use Windows, so I'm just kidding. There's also the cloud vendor reliance. So for sync passkeys, we rely on companies like Google and Apple and Microsoft to save the private key in their cloud securely. So when I was talking about sync passkeys, that's what I was referring to. Like, you know, some people just prefer to have it with them in their pockets than to sync their private keys to these type of places like Apple and Google and Microsoft. So it's a trade-off. It really depends on your needs and what you feel most comfortable with. Then we also have some enterprise use cases. So some enterprise users might want more control and flexibility over the things they can do with passwords. For example, if you are on Mac, like on your work laptop, and your company decided to disable iCloud, then you can't really use sync passkeys. So it kind of like defeats the purpose a little bit. Or if they disable Google Chrome, I don't know, I'm making this up, the Google Chrome example, then you can only use device-bound passkeys. So that is another challenge that we're facing. And then the last one is for reset and recovery. And I often get a lot of questions about this one because what happens if I lose access to my iCloud? You know, what do I do with my passwords? Like, you're depending with something very, like, you're giving something very important to someone else, right? So there's not really a default recovery flow, especially for device-bound passkeys. And applications still need to implement recovery and reset, like, on their own. There's not like a defined specification on how to do this yet. So it's kind of like a do it how you want to do it kind of thing. All right. Other than that, well, just recapping a little bit on the agenda, I talked a lot of bad things about passwords. We saw some alternatives. We talked about WebAuthn briefly. And finally, we talked about passkeys. So I think we covered all that. And where can you use passkeys now? So obviously, Google, Apple, Microsoft. You can use it. Obviously, Auth0 by Okta. And then I personally have enabled them in my GitHub account, and the experience has been nice. I discovered recently that Uber has passkeys as well, which is interesting. Kayak's experience apparently is very nice with passkeys. And then, of course, I think most of the password managers, like 1Password, Bitwarden, and all of them, are catching up to give support to passkeys. 1Password already has it, but the other ones, I think they're still catching up. But there are many other websites, really, where you can find passkeys. And adoption is growing every day. So where can you learn more about passkeys and everything that I just spoke about? So if you want to learn more about WebAuthn, you can go to this website. It's called webauthn.me. You can debug the whole WebAuthn process, see how it works, how are the components interacting with each other, what data are they sending to each other. If you want to learn more about passkeys specifically, you can go learn passkeys.io, and you can run a demo. It's basically doing what I did with my demo, but very explain you step by step what is going on, so it's more clear. Sorry. Okay. One last thing before I finish this talk is, I don't know if you noticed, but I'm wearing this electronic badge with me. This is a Pimoroni Badger 2040, and you can program it using MicroPython, and it's really fun to have. It has absolutely nothing to do with passkeys, but I just think it's fun. But We have prepared a little coding challenge. So if anyone wants to, feels like doing a coding challenge, it's a Spring Boot application. But honestly, I don't think you need to know that much Spring Boot to do it. It's pretty much done. And if you manage to complete it, I will give you one of these. I will be in the Altier by Okta booth. So feel free to scan that QR code, and then you can go ahead and try it out. I see a few phones out, so I'm going to wait a little bit here while you scan it. If you don't get to scan it now, you can also find me in the booth or the stand, and I'll be there. You can ask me about it. I only have a few, though, so I would say it's like first come, first served. All right. Oh, and the only thing is that you need your laptop to do it. So you can do it today or tomorrow, but I don't know if I'll have some tomorrow. And yeah, this has been a ride. It's been really a ride. And I'm very thankful for you all to be here. And at least it's been a ride where we didn't have to deal with any passwords. So thank you so much. No questions, right? But I'm just kidding. If there are any questions, I'm happy to take them. If not, I can just leave. Yes. No. So you were talking about this fast. Wow, was it that long ago? This side. Yeah, so the authenticator, the question was, for those who didn't listen, is so how can we guarantee that even though we're in this side, like what happens if my device gets stolen or if I lose my device, how can I guarantee that no one else gets access to my account, right? Okay. So these devices ensure that you have to use multi-factor authentication. And what that means is that you're not only using that device, but you also have to implement another factor apart from that device. For example, in my demo, I was using passkeys, but then I could always default to a password. Not that I want to, but I could always default to a password. So even if I lose access to that passkey, I can still go to my password. I would recommend setting up some other type of factors in place. Like, for example, you can use a passkey with an authenticator app, for example. So if you lose access to that passkey, you can still use your authenticator app, and then later on, you can make sure to delete that passkey so no one else can use it in the future. You're welcome. Any other questions? Okay, you can go. I won't take it personal, but I'll find you. I'm just kidding. Well, if there are not any questions, or if you just want to chat with me, not on this stage, which it would be much better for me, you can find me at the Altier by Okta stand or just walking around, and I'm happy to answer all your questions. Once again, thank you very much, and enjoy the rest of the conference.